Hello and welcome. If you're in library and information science, you already know our entire world is built on organizing and accessing information. But have you ever stopped to wonder what's really going on when you access a digital resource? Well, today we're going to pull back the curtain on a core concept of computer networking, the OSI model. And trust me, you can think of it as the secret Dewey Decimal System for all digital communication. Okay, let's get into it. So picture this. You're sitting in a coffee shop, you're trying to get into your university's digital library. You type a search query, you hit enter, and a few seconds later, boom, the results are there. But how did that request actually travel from your laptop, through the cafe's Wi-Fi, across the entire internet to the library's server, and then all the way back again? Believe it or not, the OSI model has the answer.
Here's our game plan for today. We'll start with the universal rulebook that makes this whole library search possible in the first place. Then, we're going to follow our data on its journey down the 7 layers of the OSI model, and we'll decode what each layer is actually doing. And most importantly, we'll talk about why this actually matters for you as an information professional. And finally, we'll see how this model fits into the real world.
So how do all these different computers and systems, made by all sorts of different companies, manage to talk to each other so seamlessly? Well, they need a shared set of rules, right? A standard for communication. And that is exactly where the OSI model comes in. The Open Systems Interconnection model, or OSI for short, is basically a conceptual framework. It standardizes all the functions of a computing system into 7 distinct layers. It's the reason a Mac in a coffee shop can talk to a Linux server at the library without any confusion. It's the agreed-upon language. And this whole thing didn't just appear out of thin air. Back in the late 70s, computer networking was kind of like the Wild West. You had tons of competing, totally incompatible systems. So, the International Standards Organization stepped in to create a universal blueprint, basically to bring some much-needed order to all that chaos. To really understand how this model works, we're going to follow your library search query on a journey. It starts at the very top, in the software you're using, and it travels down through all 7 layers. And each layer adds its own little bit of information and prepares the data for the next step until it's finally ready to be sent out over the network. And here they are, all 7 layers, from the top to the bottom. As your data moves down this stack, it gets wrapped in more and more layers of information. You can think of it like putting a letter inside an envelope, then putting that envelope inside a slightly bigger one, and then putting that inside a shipping box. Each layer of that packaging has a very specific job to do. Now, I know, 7 layers can feel like a lot to remember, so it really helps to think of them in 3 groups. The top 3 are the user support layers. They deal with the software side of things. The bottom 3 are the network support layers, and they handle the actual physical data transfer. And connecting them all is this super important bridge, layer 4, the transport layer. Just keep these groups in mind as we dive into the specifics of each one. All right, time for the main event. We're going to break down exactly what each of these 7 layers is responsible for, and we'll keep connecting it back to our example, sending that search query to the library's database. So let's take a quick look at all 7 layers and their main jobs. We'll use this as our map for the next few minutes. Just remember, our data starts its journey way up at the top, layer 7, and moves all the way down. We're going to start at layer 7, the application layer. This is the only one you actually see and interact with directly. Think of the search bar in your library's online catalog. This layer takes your search query and just hands it off to the network using a specific set of rules or protocols like HTTP to get this whole communication process started. Next up, your data hits the presentation layer. This is the network's universal translator. Its job is to format your search query into a standard language, maybe compress it to send it faster, and, this is a big one, it handles encryption. This is what protects a patron's login information and their search history, which, as you know, is absolutely vital for privacy.
The session layer is our dialog controller. So when you log into a library database, this layer is what establishes that connection, the session, and it keeps it open while you're working. It's what stops you from being logged out in the middle of a really complex search just because you paused for a minute to think.
And now we've reached our bridge, layer 4. The transport layer is like the quality control manager. It takes your big chunk of data and breaks it down into smaller, numbered pieces called segments. Its entire job is to make sure every single one of those pieces arrives at the library server and can be put back together in the exact right order.
Okay, from here on out, we're in the network support layers. Layer 3, the network layer, is the digital postmaster. It takes those segments we just made, puts them into packets, and slaps a logical address on them, which you probably know as an IP address. This is just like putting the library's full street address on the package.
Its job is to figure out the best possible path across the whole internet to get to that destination.
Next is the data link layer, which is kind of like the local traffic cop. It takes those packets and puts them into something called a frame. Then it adds a physical address, the unique MAC address of your Wi-Fi card, which is like a serial number for your specific device. Its focus is only on getting that data frame reliably to the very next stop on the journey, like from your laptop to the cafe's Wi-Fi router.
And finally, we hit the physical layer. This is where it all becomes real, tangible stuff. This layer converts those frames into a stream of raw bits, just ones and zeros, and sends them out as electrical signals, light pulses, or, in our cafe example, radio waves. And once those signals get to the library server, this entire process just happens in reverse, all the way back up the stack.
Okay, that was a lot of technical detail, I know. So the big question is, why does any of this matter to you as an information professional? Well, it's because this model is one of the best tools we have for a core library task, troubleshooting access issues.
See, understanding this layered model gives you a really powerful mental checklist. When a user tells you they can't access a database, you can start to work through the stack in your head. Is the library's Wi-Fi completely down? That's a layer 1 or 2 problem. Can they get to Google but not the database? Maybe it's a routing or an IP issue at layer 3. Is the database website itself giving a specific error message? Well, that points to a layer 7 application issue. This model turns the internet is broken into a puzzle you can actually solve.
Now, I have to make a really important clarification here. While the OSI model is the universal standard for teaching networking, it's not actually what's strictly used in practice. It's a conceptual framework, not a rigid law that every device follows perfectly.
The model's pros and cons really show this trade-off. It's fantastic because it's a universal standard and it's super adaptable. But in the real world, some of its layers, like session and presentation, are often just combined into the application layer to make things more efficient. The reality is, the modern internet is really built on a more streamlined model called TCP/IP. But, and this is the key point, even though the OSI model didn't win the implementation war, it is still the absolute best tool for learning, for understanding, and for troubleshooting how networks actually work. It teaches you the logic of networking. So if there is one thing you take away from all this, let it be this. The OSI model is the grammar of networking. You might not use every single grammatical rule every day, but knowing that underlying structure makes you a more fluent, a more effective, and a more capable speaker. Or, in our case, a more effective information professional in this deeply networked world. And that leaves us with one final thought to chew on. The 7 layers, they describe the technical transmission of data, right? But as librarians and archivists, maybe we should be thinking about an 8th layer. The human layer, the ethical layer, the preservation layer. As our systems get more and more complex, what new rules are we going to need to make sure that information doesn't just get transmitted, but that it remains truly accessible and preserved for generations to come? That's the challenge for us. Thanks for watching.